we're going to have a session about Testcontainer and Amazon Web Services in the cloud, Java and the cloud with Amazon Web Services. But first, I need to ask a question. Can you raise your hand if this is your first time coming to a Barcelona Job meeting? Okay, I see several hands raised. So sorry for the ones who are regular, but I need to do this presentation. We, Barcelona Youth, are a non-profit association since 2012. We have 11 years legally based here in Barcelona. We are enthusiasts and techies that gather regularly each month to discuss about new technologies, and we are always curious about everything related to Java and backend technologies. Yes, we meet several times, usually twice a month. For example, tomorrow we have another meetup as well. We gather to evaluate ideas, to discuss solutions and products and everything that helps growing the developer community in Barcelona. And everything that is related to Java world, but not only. We also have some talks about DevOps and also the cloud. If you want to follow us, you have several QR codes here. We have Twitter, where we post about our future events. When we record the talks, we also upload it to YouTube, and also some of the sessions of previous conference edition of the JVCM Conf. We also have LinkedIn, Flickr for pictures, and Meetup if you want to attend to our meetups. Some of the past events we have had in these years are about these technologies. So you can see that we discuss topics like TDD, but also Kubernetes, OpenTelemetry, Quarkus, Kotlin. So everything that is related to backend and cloud, we are interested. And we would like to thank our sponsor, Adevinta. And Gustavo, I think you have some words for us.
Hello all, welcome to this meetup at Adevinta. We have the pleasure today of having as guests colleagues from AtomicJar, Amazon, and the Java user group. But first of all, I would like to make a brief introduction about Adevinta, but really short introduction. Adevinta is a leading online classifieds company. This company Adevinta owns 25 marketplaces around the world, and it has millions of users per day. For example, in Spain, you can find us as InfoJobs, Fotocasa, Cochesnet, Motosnet, Habitaclia. At Adevinta, we connect buyers and sellers. We connect buyers and sellers, and we provide, for example, job offers, real estate solutions, cars and motorbikes, consumer goods, and more. Here at Adevinta, we are around 8,000 individuals working, trying to create the best experience possible for our users. So this was the short introduction, and I am sure you are willing to hear about our guests. So first, you will find Alex, and Edu from AtomicJar, and there will be a Q&A where you will be able to make questions. And do not forget, at the end of this meetup, there will be also in the canteen that you will find here also, there will be snacks, and there we will be able to share our thoughts and our knowledge and whatever you want with all of us. So without more dilation, I am going to pass the microphone to Alex from AtomicJar.
Wait a little bit. I need to finish my presentation. We also want to thank JetBrains And we have some licenses to share and to raffle with you. So if you are interested, reach out anytime during the meeting, and we can arrange this. And the last thing is that, yes, we want you to collaborate and to join us. So if you have any idea of a talk or of a workshop or some coding dojos, a hangout to discuss anything, or an open panel, whatever is on your mind, and if you want to share it with us, we can make it possible. So here's the email at info@barcelona.jog, and also we have some Slack channel. You can also share your ideas, open to debate. We have some interesting discussion lately these days. So if you want to join, you are welcome. And we also have a feedback sheet. So if you pay €2 to come and you want them back, I will handle a form that you will sign up with your name, and then we will reimburse you. And that's it. Alex, an applause for them.
So we'll be setting up everything. Meanwhile, we are setting everything up. So how many of you are using test containers nowadays? Okay, half. Great. So we are covering people with no experience with test containers, and we're covering people that are already using, and we will introduce something that's coming up with Spring Boot 3.1. So you will get value from this conversation. So great. So let's start. I will go there. So, are we able to connect this, or it's not possible? If you could
log it.
Yes, thank you. Okay, so Edu, first, please.
My name is Edu Melendez. I am from Peru, software engineer at AtomicJar, test containers, container since last year. Java champion too, I don't know why. Edu Melendez, you can find me at Twitter as Edu Melendez and GitHub too, and I try to blog as much as I can in that website. So.
And I am Aleix Morgadas. I'm head of engineering at AtomicJar. You can find me at Aleix Morgadas in several places. And I am not a Java champion, but maybe as a manager, I am a meeting champion. I don't know. So let's talk a little about the dark age of integration testing. So I would like you to, if you feel familiar with this situation, you run your test in local development, you do a mock, it passes. You do a mock in, you go in CI, it passes. Lucky you have a staging, you run something and then it fails with the integration. So how many of you have been exposed to some of this degree of issue when using mocks? That you do it there, it passes, and then it fails in production. Great, because we are here to solve this. So then you only don't have this, but you also need to use it in your local machine. So usually you have your integration and you need Postgres or you need something else. And then you need to start like, okay, I need to start my infrastructure in local. And then you start it, run the test in local, you see the error, and then you need to stop the infrastructure later. So you start this thing about status H. And how many of you use Bash to start your infrastructure when you don't have test containers? So some of you are doing this kind of testing, multiple people, great. So this comes because some time ago, this was true, where unit testing is cheaper to run, therefore you do a lot of them, and you need less and less about end-to-end and integration. So this applied for several years until there was one that said, like, don't worry, look at the night, and we will save you here. There are two main authors of this code. One is a strange wizard in the Middle East, and the other is test containers. So how test containers comes to rescue in these dark ages? So we will see that before you were using like outside your JUnit or your framework of testing, you were setting up things, and then you were setting up outside your testing lifecycle. With test containers, you are integrating how to start your integration dependencies inside your code. Therefore, you are having explicit dependencies, and you are using it inside the lifecycle. So you're removing this start infrastructure or cleanup infrastructure, so you have all the stuff integrated in your testing suite. So you are running this in local, you're running this in CI, and now you're able to identify that you have an issue with Postgres. So you have been able to avoid an issue in staging or a potential issue in production, thanks to this. So it was an improvement over there. So why this is important? Because you are able to catch issues faster before getting into production. Great. This started with Java. And this happened around 2016. No, 16? Where's the first one? Or earlier? I don't remember right now which was the first commit. So it started like having this concept everywhere. So instead of having like that implicit dependencies, you have them explicit. It was that popular that it was solving that many issues in production that given a point, it populated like from, it started as a library in Java and it started continuing with Go, .NET, Node, Python, and a lot of them. We as a company, we are sponsors of the implementation, which is from Java, Go, .NET, Node for now. So we have been scaling and so on and so forth. So it was having a huge adoption from there. And at the beginning, we only was using containers. But we will talk about the Java one, which is open source and using JUnit and JUnit 5. It's great. And why people were using us? Because instead of using mocks that you need to learn, and I don't know if it happened to you, but you go to something, it fails in production, you change the mock, and you're like having at the end of the day a mock that replicates your infrastructure full. So I have been there. So instead of having that mock, which is super big, you have a real dependency. So now you're, instead of using Docker run to start dependency, you're able to have them implicit in your test, and you can just have this clone and run experience where it starts all your infrastructure when you need to run the test. It was that experience that we started having a lot of models. So instead of having them like you need to code them as explicit, you just import some dependency from all these technologies. And I will have a short list because indeed this is in public, but we have a lot of databases that now we have generic containers that you can just import and say, okay, I have Cassandra, I import this model, I can connect directly. MySQL, Postgres, I don't know, like Yugabyte, Kafka, Pulsar. So you see how this improved, like, oh, this is very useful for me. So it started expansioning all the models. So everything which is infrastructure, people start adopting test containers and extending it with models for their dependencies. So really removing all this boilerplate and making it easy to test with real dependencies. All of this happened, and then we have the starting of the Spring Boot and other services that started adopting these test containers in their Spring Boot or their experience for developers. And you can see how test containers influence it, and this is why we're having this conversation today, how influence it the developer experience that the frameworks are giving. And now we will see a short introduction about how Spring Boot start using test containers to improve your life with testing with real dependencies. And I will give this space to you, Ed.
First of all, who is using test containers already? Raise your hand. Okay, nice. And Spring Boot? Okay, cool. So both together? Anyone? Okay, great. So for you that already know this this feature, maybe there is an annotation which was introduced in Spring Framework 5.2.5, and that dependency becomes available in Spring Boot 2.2.6, if I remember correctly. So starting in that version, in that Spring Boot version, you were able to do that definition of the container, Postgres container, and with the container annotation. So test container will manage the life cycle of the container itself. As you can see, we are also defining the image that we want to use. So test container will be pulling the image from Docker Hub. It will start the container. It will, in this case, using the dynamic property source and the dynamic property registry, we will be setting the Spring data source configuration properties with the values coming from the container itself. Why we are doing that? Because this container will be starting those containers on random ports. So we don't know the port, and thanks to the get JDBC URL, we will get in that URL instead of just guessing which one it is. Why we are doing this? In order to run parallelized tests and run it faster. So this was this is nice to have. Indeed, there were some other ways to do it in the past, extending a class, adding annotation, context, the context initializer, stuff like that. Then there was also another kind of integration because test containers has its own container JDBC driver. So we were able to do something like that. It's like a hat, but it's nice when you want to replace H2 with another database, for example. You just replace it. Far, it has been very cool. However, if you have many dependencies like Kafka, Redis for caching, database, so it will be like two more probably records there, line of codes. So it's kind of, you need to remember the property, you need to map it, mistakes can be done, right? So there is a new concept coming in Spring Boot 3.1, okay, which is connection details and service connections. This will become available tomorrow. So tomorrow you can just start. If you just like to experience new things, you can try snapshots. Yes, I do. Otherwise, you need to wait for that for tomorrow. And currently in Spring Boot 3.1, there is support for service connection for Cassandra, Couchbase, Elasticsearch, JDBC. That means all the databases that Test Containers provides already. Kafka, Mongo, Neo4j, R2DBC, the same. We currently support for MySQL, MariaDB, Oracle, and MySQL Server. RabbitMQ, Redis, and Zipkin. If there is a service at which you are using and it's not listed here, you can just continue doing the dynamic property registry. Otherwise, you will get something magical. So if you are using Postgres, you don't need the other 5 lines, the dynamic property source, neither the dynamic property registry. You only need the service annotation in your Spring Boot will automatically do all the magic. Of course, it's not magic, but it will configure all the properties for you. That's cool. That's the kind of experience that maybe we are looking for because we want to write less lines of code. There is also, well, this is a test containers feature itself. This is the container reuse mode. We used to do that for development purposes. Sometimes we need to run the service by ourselves, like not only in testing, but running the service, right? And we need to, I don't know, maybe reuse the same database for some reason, the same Kafka instance. For example, if we are working between a consumer and producer in order to send a message and that message to be read by another application should be shared the same instance of Kafka, for example, we can use the reuse mode. And what it means, the reuse mode. So one application can run the service itself, database, Kafka, for example, and then other database with the same container definition can read the same container just by itself. There are more information about this in that link.
One question. How many of you know about reuse? So it's true that it's a feature that we don't sponsor a lot, but makes a lot of sense. So if you are using test containers and you're not you don't know this feature, it's really awesome. So for the things that he said, so really check it out because it might speed up your test environment like by a lot.
Thanks, Lish.
So with test containers, we solve somehow the testing phase. So right now you have you saw like that add container service thing. So now you have all your testing flow in local or CI as this. We're using JUnit and Java. You're able to test everything with only code. What happens is that we found that people is running your application locally using Docker Compose app. So you're using test containers, but how many of you are using also Docker Compose to test in local, like when starting the application? So how many of you are using Docker Compose? Okay, so now with the new Spring Boot, we solved this for the last years, and what we are now solving is this part. Like we are able to test the dependencies. Now we're going to see how we can use the same mindset about using your application locally and starting it using test containers. So let's solve this part.
So Spring Boot and test containers at development time. Spring Boot also, it's improving the experience in order to use test containers when we are developing and running services, okay? Who has been using Quarkus, dev mode, Micronaut resources? So the experience that you will get here, it will be the same. It's finally arriving to a Spring Boot, so okay. And now we will be able to define a main method. We will have a class in the test class path. We will define in the main method, and then we will have something like that. Spring application from, and we will call in the main application. The producer application in this case is in the source main Java. And then we will say, okay, this is my container configuration. And that container configuration belongs to the same class as you can see there, but it's my test configuration, which only defines containers, right? It's with the bean annotation and the service connection, because the service connection in this case, it will be doing the magic thing about filling the Spring configuration properties with the values coming from test containers. And in this case, we are using Kafka. We are using the version 7.3.0, and we are using also reuse mode there. What else? Okay. So we said already that you can use the service configuration and the service connection annotation, but in case you don't have it for the service or container that you are trying to use, in this case, for example, test containers provide a Pulsar container class, but Spring Boot does Pulsar connection itself. The team is planning to do it when Spring Pulsar is coming to Spring Boot, hopefully for 3.2 in November, but you can do it by yourself. So this is special, and you need to be careful here, because only those beans defined by test containers, like Pulsar container, JDBC container, stuff like that, will allow you to inject the dynamic property register, okay? And then you can set the property. In this case, if you are using Spring Pulsar 0.2.0, then you will be able to use the Spring Pulsar client service URL and get the the broker URL from the Pulsar container itself. So this will start the application with your Pulsar dependency.
So you see how we move from some of the past we saw how we do testing in local and CI, and now with this thing that it was available in Quarkus before and Meetup, now we have the same in Spring, so that we can run the application locally without Docker Compose. We just use test containers, and then we create the infrastructure beans, and now we are good to go. So clone and run becomes available not only for testing, but also for local running the application. So that's what we are seeing here. That's the next evolution that we are providing us as the combination between test containers and other frameworks using us.
Okay, so in order to do that, well, you can just run the application because it contains a main method, but there is also a new task, a new goal for Maven and Gradle plugins for Spring Boot. So if you're using Maven, then in the past, you used to run the application using Spring Boot run, and in Gradle, it was boot run. So there is a new goal and task, which is test run, or yes, boot test run in Gradle. And yes, this is available in the new version. Well, now we will have the best of two worlds. Spring Boot providing support for test containers, and test containers providing basically the reuse mode. You can use, for example, the Spring Boot DevTools, who has been using that dependency, because it's like something that I think is not that common to use, but it's pretty nice because you can just make changes and then just rebuild the application in your IDE without restarting the whole application, and your changes will be available immediately. That's pretty nice indeed. So in that case, the Spring Boot DevTools dependency, it brings a restart scope, which is an annotation with a specific scope for Spring. If your bin is annotated with that one, then you will be skipping the recreation of that bin when trying to refresh the changes in your application. So along with test containers reuse, you can just skip the recreation of that container. You can keep the state, your container running, and the state of the application instead of altering the state, like the records, tables, stuff like that. It's pretty nice experience. And well, the only thing that you need to do is you need to do two things here. It will be the restart scope and say you want to use the reuse mode. Also, you need to do a change in your test containers properties file in order to opt in for the feature, because this, as Alish already mentioned, this is an experimental feature still, but it works, and it works nice. Okay, so now let's go to the hard part of this session, which is live coding. And today I've been very slow typing, so sorry about that. I think that works. Okay, so I have a small application here. It's an application with talks. We have a record. It has an ID, a name, a speaker, a repository for that one. Where the table will be talk. The ID is in string. The controller, which will return all the talks. Okay, nothing fancy. And this is the definition of the application that comes by default by Spring Boot. And we are using Flyway here. So Spring Boot will, Flyway and Spring Boot will manage all the database changes by itself. I don't need to do anything here. And there are two talks in this case. Who is attending to Spring I/O tomorrow? No? Anyone? Okay. So go to the sessions. Okay. What else? And we have some tests here. Okay. The first one is we are just making sure that it will work. And in this case, for example, I will just add the data JDBC annotation with the property that is the test containers JDBC URL. And I need the other annotation in order to let Spring know that it should not use embedded databases. Okay, so I will be roll back here just to make sure that it's not running. Okay, let's make it fail first. It fails, nice. Then we will do these changes, run the test again, and I hope it works. Yeah, because we are in a live session, so it can fail. I told you. Oh. Why we need to do live sessions? Okay, let me do something. I think I told you it will fail. Okay, So now it works. There was some setup in my machine. So if we look at the logs says that it find a Docker environment. It will be using, well, Ryuk. If you see this container running, Ryuk, who knows Ryuk already? Ryuk, the Shinigami Death Note, right? It has the same role here because it's in charge to kill the containers in this case. And we also can see the Postgres 15 Alpine running here. So we will be running this test against a real database. And yep, it works. So this is one way to do it. It still works. Nothing has changed for it. And now let's go to the other one, which of course we are annotating with test containers because we are doing something like this. We are defining our container, Postgres container. We are using the same image, Postgres 15 Alpine. And in this case, of course, it will not work because it doesn't know about, even we are defining the container, we are not telling Spring Boot about the properties, okay? So in this case, what we need to do here? Now, I am using 3.1 already. Add service connection. And I forgot something important, very, very important. This is very, very important. You now will have a new dependency called explicitly Spring Boot test containers. So always remember, what's your favorite thing? Spring Boot test containers. That's favorite Spring Boot. A favorite library, testing library, test containers. That's it. And then, okay, I just added the notation. And it should work. Nice, it works. It works. So, what else? Well, here it's the same. In this case, we are, well, in the first two tests, we are using a slicing test. That's the reason why I'm using data JDBC test. It will only load all the JDBC stuff for Spring Boot in this case. The same here. But what if I want to test my whole application? So in this case, I am using the Spring Boot test annotation with the web environment for random port. So I will get a random port for running the application in test. And currently, of course, it will not work because there is no database, right? So same thing here. Nothing more to remember. Service connection, and then we will run, and we are expecting two talks in the JSON. So yeah, the context is fine, and the sessions are returning the expected talks. So what else? Now we can, currently we have been just testing our stuff, which is cool, but now we can try the dev mode. So what it means, let's do the Spring application from, how it's called application, docs service application, main, main with containers config.class, run args here, and then test configuration, proxy, test configuration, now proxy false, static class container config, container config, and then here we will be defining our bean. Since there is already support for Postgres service connection or JDBC service connection, we can use the service connection here too. Let's define the Postgres SQL container. Postgres container. Return new Postgres, Postgres 15 Alpine, right? And then containers config. Okay, nice. And then we can just run the application. And the application, of course, just like in testing, if there is no database, it will not start correctly. And we put the database there. So the test passes. In this case, for development mode, it will be the same. So if we go to Docker context use desktop Linux, then we will see a container running. Well, two actually, because there is Ryuk, and then there's the Postgres container running there. And what else? What I can do, the HTTP, and the two talks that I submitted to via Flyway, and that you should attend tomorrow if you are going to Spring IO, are there. Right there. And I am testing locally my service with a real instance of Postgres service. So what else? I think I have already. I can show you something more. And for this one, I'll use. Sorry for switching just a lot. I can use Pulsar. Let's use Pulsar. Okay. What? No. Okay. I am living the life with EAP versions of IntelliJ. As you can see, everything can fail when I am doing this because using snapshots, EAP versions, that's my life. So Pulsar, okay, here we are. Okay, this is nice, and I will show you, I already showed you through the slides, my application, in this case, the producer, of course, it produced just a message using a Spring Pulsar.
Could you be bigger?
Oh, sure. Yeah.
Thank you.
Sorry. European Center presentation model. Okay. So this is very simple. It will be sending every second new message to a specific topic, okay, to Pulsar. And then this is the producer. And of course, the consumer will be reading those messages. Okay, nothing fancy, just testing stuff. And we have the application for those in test mode in order to run it. So as you can see, I am not using the service connection. I am using the dynamic property register instead and just setting all the stuff. So both configurations are the same for the producer and the consumer in this case, but not the application. So the only thing that I need to do now is what is? Okay, terminal. And let's go to the producer. Okay, first of all, okay, no, let's do this. Producer, and let's do Spring Boot test run. New goal, remember, new task, and yeah, it failed. Yeah. Because I don't have my environment properly set. So now it should run. Yes. And why is it failing? Yeah, because it's a live session. That's the reason why it's failing. Okay. Sorry. Okay, I need to figure it out. This, to be honest, I'm not sure why it's failing. I can switch to. We can give it another try, but with RabbitMQ. It's pretty much the same example. Yes, there are some containers which cannot run in a M1 just like this one. So environment. Okay, it's running in this case. And then the consumer, right? The same thing. Come on. So if we go to the terminal and run the Docker PS, we will see we have two applications running, but we only have one RabbitMQ in this case. That's the reuse mode that we are using because we have the same definition. We are just saying, okay, start RabbitMQ, the same version, of course. Otherwise, it will start another container. And as you can see, the consumer is just consuming the message produced by every second by the producer itself. So both applications are running using the same instance, and everything has been produced through the code that we have been through the code provided by the Spring Boot Testcontainers integration itself. Okay, and that's the demo. Thank you.
Great. So it's a demo, but not the end of the presentation. So how many microservices you use in weekly basis? So you use one repository. So how many of you use more than 5 microservices per week? Like more than 5, right? So this is start adding more things into your laptop. So you're having more resources. What happens if you were to test things, integration between a lot of them? So why we say that looks cloudy? So we're thinking like, okay, we solved the thing about integration testing. Now we're solving the thing about developer experience in developer mode. What happens if we keep adding more things and we kept starting new containers and more things as we have more and more infrastructure dependencies? So we're not moving into having monoliths. We're moving into having more dependencies, more microservices. So local developer experience will become harder as our machines have limits. So this is an example, like we're still using Consul, Kafka, Postgres, MySQL. So a lot of things are keep adding. And if you want to test things sometimes that you are looking in the same team with multiple microservices, it keeps adding. So this is, I try to make some AI thing, but yes. So it's your CPU and RAM are crying, they're not keeping up. So you have limits. So how you can unblock yourself and still having more containers, sharing and not limiting your machine to your testing thing. So this is what we call the next thing. So where you are running short on resources, you are running short on like you want elasticity on how many containers I can use in my local machine. It is Testcontainers Cloud. So what we have found is that as the thing become more complex, so when you're starting, maybe you have one Postgres, you have another thing. But now we have more things, and my machine, I was giving 8 GB RAM laptop. I was not able to keep up with IntelliJ, Slack, and containers. So what allowed me to externalize that workload of cloud containers and still being able to use test containers and testing my local machine was Testcontainers Cloud. That was before I joined AtomicJar. So that's what the reason why I joined AtomicJar. So now, so instead of having all your compute in your local or in your CI, you can use Testcontainers Cloud and offload those resources into the cloud and offload those things. So sometimes when you ask beefy machines in CI, it becomes like not much available and it becomes more expensive. So why not just offload those resources into the cloud? And that we are doing. So what we have is an agent that is you can use in your local or you can use in your CI, and we run those containers into the cloud and give you a isolated virtual machine. So we consider that as there are more adoption of this, it can happen that the local resources of your machine can become a bottleneck. So now we are giving you a tool that you are able to just not have those limits. So we are looking forward that you don't stop testing locally. You are not to stop You don't stop running things in your local, trying them before hitting CI, before hitting production. So the life cycle, it's shorter. So we are always we want you to have shorter life cycles, deploy with confidence, and we have been doing that with test containers. Now we're continuing doing that with developer experience, and the next thing will be like helping you with the cloud so that you don't run out of resources. And we won't give you all examples that Edu has been providing. So if you want to do like a picture of something, it's available there. So you have examples with Kafka, Pulsar, Rabbit, SQS. You have everything there. Okay, I will wait.
I've been testing Spring Boot test containers integration extensively and very hard until today even, because tomorrow is the release. So if you have any question regarding to any kind of integration, just reach out. I will be really, really glad to help you.
Exactly. And yes, more resources like module catalog, things like the cloud, where it reaches, like in Slack. So everything that you need, we will give you have a picture. Otherwise, you can talk to us later. So this is something we're doing tomorrow. So if you want to have a developer experience happy hour, reach out to us, because we will have something like tomorrow at 8 for some time. So just reach to us or use the QR code to register. We also have a tweet linking to this. So if you want to join us, feel free. And thank you very much.
Okay, I didn't see that coming. There is a PR. Sorry. I mean, if it please go.
We were building our stuff using local machine and Docker and now local machines. I don't see I will have Podman.
Okay.
And with Ryuk, we hit some issues.
Yeah, I know.
You know.
Yeah, I know. I know. I also know that there is a PR in test containers Java, which is adding testing of the whole suite against Podman, and it's working. Only Docker Compose is failing because we are using the link flag in Docker Compose. But yeah, we need to explore those cases for Podman, because currently, as far as I know, it's working. It's not something that we can say it 100% it works, but for the PR I saw, it's working at least. But if you can just share your experience with that, just let us know, please. Yes.
Yeah, it's about test containers cloud. So basically, which is the benefit if I'm attaching it on GitHub? If I have my private runners, or even if I'm using GitHub runners, which is the benefit paying test containers and having this in the test containers cloud instead of just simply running in my runners?
Yes. So right now, we're solving multiple pains, where the main pain that we solved was the people that were unable to reuse test containers on their CI because they have limitations. We enabled them. That's the first benefit. But if you, for example, have your own runners, there are features that are coming to solve those pains. For example, like what happens if a CI fails and I don't know, I cannot inspect CI containers. So it's more like we're extending the features. So CI is like you run, it works fine, but what happens when it doesn't run? So how I debug these things. So it's more like into developer experience. I think coming, it's true that at the current stage, if you have your own runners, maybe it doesn't see full value. But the more things that are coming, it's focused more into, okay, as a developer, the CI fails. Okay, why? Which was a state in which this one failed? Okay, it was this one. So debugging in CI sometimes becomes tricky. As myself, I was looking logs. Like, what happened here? Put a log, wait for CI. Okay, come back. So what happens if I just can debug it, put it there, and then have a shorter life cycle? So right now, it's we're enabling people that are unable to use Dockers in CI. We enable them, and more things are coming for the people that are able to use it, but we need to extend that behavior. So that direction. Thank you for the question.
Any further questions? You have another.
Well, first of all, I think the integration of test containers improved a lot with Spring Boot, but when we compare with Quarkus, I think it's still missing something. For instance, in Quarkus, we will add the extension, and Quarkus will start the container automatically. We don't need to add any annotation, anything related to the test containers. There is any plan to get in the same stage that Quarkus run test container?
I think that's an opinionated feature, I will say. I do not belong to the Spring Boot team, but last time we talked about it, in this case, Quarkus, as you just said, you just add the dependency and it will boot the dependency, the container. That's nice. But in case of Spring Boot, as far as I know, they don't want to run a specific version of the container because they want the users to define that. Because you can change it. Yes, that's right. That's right. But most people, I don't know, can use it by default. I don't know. But that's what Spring Boot don't want to do. Like just boot the container, whatever version they don't. I think it was just Ron who said something about they want to make sure that you are running the version that you want to run. So that's the reason why you are doing that, basically. If you forgot, in this case, in Quarkus, you are running another version. It's not bad. It's not bad, indeed. But that's...
But if you want, you can specify the version.
Oh, okay, it's using latest. I didn't know that. I didn't know that. Okay. Yeah, but I think this is opinionated in the framework itself. So as far as I know, Spring Boot will not do that. That's what I can just, so yeah.
Okay, we have room for one more question.
I will just add one thing into your question about which is the add. So sometimes we found that some teams are unable to change their pipelines because the pipeline CI belongs to another team. So what happens if we want to use test containers, but we are not empowered to change the CI system? So with using this, we just enable you to use the CI containerization, or sorry, a VM, so that you are unlock yourself. So you are not locked using like, hey, please, can you add this to us so we can use test containers? So you use us and we enable you. So that's sometimes a pain that we found and that we are solving. So yeah.
Okay, any further questions? It seems not. So many thanks for your presentations and a big round of applause for them. And who wants to build a cloud-native Java application for the cloud? A lot of people.
Gracias. I ran out of battery. My kids must have been playing with it.
Yeah, okay.
¿No tienes una pila por casualidad? Que sé que mi hija le deben haber jugado con esto. Ah, vale. Vale. Ok, perfecto. Espera que apago esto que me está viendo. No sé qué es eso.
Yes, well, hours. I'm using hours.
So then I will take this off.
That's fine.
Which is the.
That's for there.
Maybe with
Yeah.
there.
Yeah,
Okay. Yeah, I have exactly the same. Yeah. Okay. Can everyone? No, it's not working.
It is.
Okay, it is. Okay.
We don't see the presentation.
Hmm?
We don't see the presentation.
No, it's here.
Oh,
Okay. I'm going to stand over here. So, who knows AWS? I do. Yeah. Okay. Good. A lot of people. Okay. Who knows serverless on AWS? Who knows? Okay. Okay. So some parts can be quicker. So, welcome. We're going to talk about Java for cloud native applications. How to do that? Everybody knows how to run. Everybody in the room knows how to run Java applications. Let's see how you can do that in a serverless way. My name is Kevin. I'm a solutions architect at AWS. And in a very, very far away past, I was also a Java developer, but it's been a couple of years since I've written some code. I'm going to present today together with Melina.
hi everyone. I'm Melina Schweitzer. I'm also a senior solutions architect at AWS. My background is also Java developer and architect, and been with AWS now 4 years. I do a lot of Python now, sorry. But I'm still very much interested in this topic, and I'm trying to, go ahead with the breaking ground for Java on serverless.
Okay, so we're going to talk a bit about Java at Amazon. Okay, there's a screen for me. Okay, good. We talk about migrating and modernizing Java applications to AWS, on AWS, and then how to run it cloud native, and then also what it means. Can we maybe close the blinds a bit? Because otherwise people will not see the slides. Yeah, that then they can see me better. And we talk about the developer experience, because in past conversations with customers, they are sometimes afraid of cloud because it's serverless, so that means I cannot do it on my laptop. Well, no, that's not true. There is a yes and a no in there. I usually say then to a customer, well, it depends. That's my favorite answer to any question. It depends. For some of you probably as well. So you will hear me say it. If you ask questions, most of the time the answer will be, it depends. Okay, Java is the most popular programming language. Anyone in the room that does not agree with this? No? Okay, otherwise I was going to ask, please leave the room. But it's not only we saying at Amazon, it's also external analysts that do this when they do surveys. And what that means is, well, we also use Java extensively, so much that at some point it made more sense to have our own GDK than to use the one from the Open GDK or the evil one, let's say, from Oracle. Why? Because we have we have thousands of machines or more, tens of thousands of machines where we run Java on at Amazon. Now, when I say Amazon, I mean Amazon and everything. When I say AWS, it is the cloud. So we have our own version. Not going to stay too long with that. We upstream changes and bug fixes to the Open GDK as well, and it's used extensively. You can use this version, on your laptop wherever you want, but you can also use OpenJDK or something else in AWS. So migrating and modernizing to AWS. Well, the relocate, rehost, the migrate is not going to make a difference for a Java developer. You continue to develop on your laptop, and once you are comfortable in saying it works on my laptop, you can move it on, and it's for others. If you're going to re-platform, it's basically the same. It works on my laptop, and then at some point, after some issues, they will force you to also run it in a Docker container on your laptop, and then you can say that the container runs on my laptop, and again, it's for others. What is the modernized part then? That is the move to open source for different reasons. For some, it is because they believe in open source and they want to use open source products. For others, it's licenses they want to get away from. And that's also something that will not have a big impact on you. It's moving from, for example, WebLogic to Tomcat. As a Java developer, especially with Spring Boot, you're not going to be impacted a lot by that. It is the last one, the move to serverless functions. This is a bit different. And that's what we're going to talk about. And okay, we say there, monolith to microservices. You can also run a monolith on a Java function, on a AWS Lambda function. I don't encourage it, but it is possible. And what we can see then is that, and why? When we say cloud native, we mean serverless. Why? Because if you see at let's say the history of compute, we go from physical machines to virtual machines to containers, and now we're in the serverless phase. I don't know what the future will bring, but serverless, what is the big advantage there? It is a continuous scaling up and down. You don't have to worry about that. That is a serverless part for you. How many servers does it run on? I don't know. I don't care. It is also the fault tolerance that is built into that system that allows you to have your application be more performant. Because if it runs on Tomcat or WebLogic or whatever, and you have to scale up or down, sometimes it is a challenge to do it well. And then the big advantage of serverless is you pay for value, meaning with everybody knows how it works in the cloud, pay as you go. Yeah, well, you pay for what you use and nothing else. Having your function there doesn't cost you anything. If it gets invoked, then it costs you. And that allows you then also, because it's serverless, there is zero maintenance for the infrastructure for you. Not for us, but for you, there is zero maintenance on infrastructure. The only maintenance you have to do is on your code, which also leads then to, you can focus on your business logic, you can focus on what brings the added value for the business. Everybody knows this. I don't think I have someone in the room that does not know how a three-tier architecture looks like on a, let's say, on-prem environment. What does that mean in a cloud-native environment? Well, not that much of a difference. Still 3 tiers. That's my okay here. We have a presentation layer where we can have mobile apps, where we can have Amplify, or you can have everybody. Does someone not know Amplify? Who knows Amplify? No. Okay. Let me quickly explain. No. Let's ignore Amplify. Run your JavaScript, so your SPA, what is it again? Single page application with Angular, with React, with whatever. You put it on S3 and give it a URL, or you put CloudFront in front of it, and you have your front end running. And you don't have to worry about servers at that part either. And then the business logic, you can have Lambda functions, or you can have on the other side, the example here is Fargate, which is running containers serverless. And you have event bridge and event bus in between for an event-driven architecture. You don't have to use everything on the slide here if you want to do it in a cloud-native approach. It's just an example where we put most of it on. Everything that you see on this page is using APIs to get created, to get destroyed, to manage, and so on. Everything is API-driven. All the services are API-driven. So that's also something interesting. And then you have your databases. Then I have to look at this one is DynamoDB, serverless NoSQL, key value pair, the middle one. The left one is Aurora serverless, so PostgreSQL, MySQL serverless, and the other one is DocumentDB. How should I say that one? It's our service where we run a MongoDB like database. So the core, if you look at this, the core for the business logic for your Java code that is here, Lambda and then Fargate. But we will talk about Lambda in the next part. Not on this part. Huh? Yeah, after this. So that also means serverless, it is more than compute. Huh? So, some people think serverless, that is only functions and that's it. No, it is functions. It is also serverless containers, but it's also different types of data stores. And it's also different integration services. Event bridge that I mentioned on the previous slide, you can see it here. The third one at the bottom, it's a bus. You can have your RabbitMQ. You have Amazon MQ, but that's not serverless. But a serverless version is Event bridge with other functionality that is also natively integrated with a lot of things. SQS, simple queue service. Again, RabbitMQ, for example. So serverless, it is more than compute. However, we will talk about compute for the rest of the day. So let's talk about Lambda. It's a serverless event-driven compute, and I'm going to let Melina talk about that, what that means for your Java applications and what Lambda is.
All right, let's see if I can get close enough to the TV to be able to read it. Can you hear me well? All right, so let's talk about the serverless functions that we have here, our service called AWS Lambda. Went back. Okay, so what is it? So for those of you that are not familiar, you can just think of it as a function. So instead of thinking of your applications as an app with a bunch of functions, it's just one function that executes. Now that function could be your entire app if you want it to be, or it could be a macro service, or it can just be a small microservice. That's up to you. But anyway, so how does that work? All of the Lambdas are all event driven. So basically you're going to have an event source that triggers it. And then it also will trigger other services for you, depending on what the Lambda does. For example, if you have a change in data state, it can trigger your Lambda to process a new record, for example. You can just invoke it through an endpoint, through API gateway, for example, as well. Or it can also track changes in resource states and then trigger itself to do specific things. It can be written in many languages. Obviously, we're mostly interested in Java functions. That's basically where your Java logic is going to sit. And then you can trigger things like, the results of this Lambda is going to go and be saved in S3, which is our object storage. It can go into Dynamo or NoSQL database, or it can go into a step function, which is sort of like a workflow service. So you can do, and there's many other things that can trigger it and many other things that you can sort of funnel the results towards. So it's very flexible. All right, so we talked about what is behind and after the Lambda. Now let's talk about how we invoke the Lambdas. You can have a synchronous invocation. Basically, you hit the endpoint for the Lambda and you wait for the response to come back, right, with whatever results. That is the case, for example, if you have API gateway in front of the Lambda. It's basically our HTTP routing. It's going to invoke the Lambda, it's going to wait for the result, and then it's going to ship it back to whatever called it. In this example, it's just executing the route order. You can also invoke it asynchronously. So for example, SNS is our notification system. You can basically, it's sort of like a publish and subscribe kind of a service. It can actually have as a target invoking a Lambda, and it'll just pass the payload. It can also be invoked by S3, so our object storage. So let's say a new file comes into the S3 bucket that is being actually monitored by the Lambda. So that's going to trigger the Lambda to invoke itself, and it's not going to wait around for a result. It's completely asynchronous. So you can also have a polling kind of mechanism where maybe you're getting a bunch of data from Kinesis, or which is our data analytics engine, and it just all gets dumped into your Lambda so that it gets processed. That's basically lots of ways that you can actually have the Lambdas invoked. All right, so now that we know sort of what it is, what's invoking it, how we can invoke it, let's talk about the performance. So there's a big sort of black cloud on top of Java Lambdas. It sort of has a bad reputation that it's very slow. That is compared to Python Lambdas, no Lambdas, and so on. We're going to get sort of into the why this is sort of like, that myth exists and what we can do to overcome it, basically. So we have basically an example Spring app that's running on this Lambda. And here you see the graph of like 10,000 requests that are coming in. You can see that, we have the vertical axis, which is basically tracking frequency. So the more you execute the Lambda function, the smaller the latency is, right? So the latency is growing towards the positive X. So the more frequent you invoke it, the less latency you are going to have. And when you see when you have like a smaller Y value, that's least frequency, and you see it that it can be, it can actually grow latency wise. So the least you invoke it, the more chances it's going to take longer to process that request. So let's see why. All right, so this is basically what we're going to call a warm start. This is that top mountain. Basically, that means that at a high frequency of invocation, we have a smaller latency. And what that happens is the Lambda goes into its invoke phase. You're just running whatever logic is inside your Lambda handler, your function, basically. What we were observing here is around 10 milliseconds for average for that, just that phase being invoked. Okay, now let's look at the little mountain over there. That's the very terrible cold start that everyone is scared of. So what's happening here? You have two phases now. You have an initialization phase as well as the invoke phase. So the initialization phase, as you can see, takes the meat of the latency here. So what's happening in that initialization phase? This is something that is, common to basically Java, because Java, in reality, it's not really made for short processes. It's made for servers that are going to be up and running weeks, days, many hours. And the optimization is really built for those long-running jobs. So it's, it's doing performance tuning, garbage collection, and just optimizing depending on, what the load is. But what we have here is you only have a small function, right? It's in and out, and it's gone. So the initialization phase occurs. And basically what that means for Lambda is you're going to create an execution environment. You're going to download the code that you need to execute. You're going to start the runtime. Then you need to do the initialization, the Java-specific initialization, right, of class loading and whatnot. And then finally, when all that is done, then you finally invoke your logic. And that part is, still very quick, but that init part basically eats up the majority of that latency, and that's called a cold start. All right, so here we see the Java initialization, what's happening, right? Like I mentioned, the class loading, the just-in-time compilation, runtime dependency injection, right? If you have like a framework such as Spring, that uses a lot of dependency injection, that takes a long time to get processed and initialized for your Java environment. And that's basically where the majority of that latency is getting eaten up. All right, so we just covered cold starts. Now let's see if we can make it warmer somehow. All right, so one of the easy tools that you can actually use is called the Lambda Power Tuning. And basically, you install that, it's going to look at your Lambda, it's going to run some tests at different memory levels, and it's just going to basically spit out a graph such as that one. That's going to tell you, okay, by cost and by time, what is that, like, where is your sweet spot, basically? Right, you can assign up to 10 gigs of memory to your Lambda, but then it's going to cost you. You can also assign 128 megs, but then, you might have a slow function basically with a huge cold start. If it starts thrashing, even worse. So anyway, so this tool is basically going to analyze all that for you, simulate all those scenarios, all those different configurations, so that you can make a good educated guess, as to where you should be, right? What's the best memory setting that's gonna give you what you need at the lowest cost. So that's definitely something to look at if you need to optimize your Lambdas. All right, so before we keep going, I just wanted to talk a little bit about concurrency. Like, how is this happening? Like, what does the cold start and the warm start look like for, concurrency, basically? So on your first invocation of your Lambda, you're going to have that initialization and you're going to have the execution phase or the invoke phase, right? So now let's say that 2 other invocations come in. So your second invocation comes in as the first one is still being processed. So the environment that got set up for the first invocation is busy. It can't take the second call. So we're going to create a second environment. All right, well, the first environment is doing that. The second environment is doing its thing. And then a third invocation comes in. At that point, the first environment is done. So the third invocation goes to the first environment, which is still warm. You don't need to initialize. That's what a warm start is. Basically, you're recycling, not recycling, that word. You're reusing the container that's already loaded and ready to go. So that second invocation is going to not have that initialization phase, and it's going to be much quicker. Okay, so that's basically what the Lambda concurrency looks like as invocations come in. All right, so at the end better, yeah, thanks. Okay, so what can we do to make the concurrency, the cold start, a little bit more performant? All right, there's several things that we can do. One of them is going to be to, for example, instead of packaging up a zip with a lib and several packages inside, what we're going to do is make an Uber jar, sort of like what Spring does with the Shade plugin, right? You want one jar with everything in it, and that's going to load a lot faster. You're going to look in your Java dependencies, your POM XML, for example, make sure that you're only really installing the libraries that you need. Keep those to a minimum. Choose the libraries that are more lightweight versus, heavy libraries like log4j. You have to keep in mind that, you need to package for small, right? So keep it as small as possible. An easy thing to do is to enable tiered compilation. So as I was saying before, Java usually, it was really made for long-running jobs. So the profiler, everything is really made for, making things better the longer they run and the more executions you have. We have the opposite problem here. We need something that runs, that maybe is going to initialize, and scale rapidly. It's not going to be the same process running for, weeks. That's not going to happen on AWS Lambda. So what we need to do is change the JIT compiler that we want to the C1, which is actually from C2, which is favoring server, long-running jobs, to a C1 compiler without profiling. That's going to favor, initializing quicker and not worry about profiling. Because anyway, profiling, it's really just, you're going to have some performance gains if you have executions over 10,000. And that's unlikely on a Lambda environment. So that's the way you set it, right? This is actually an environment variable that gets added to the Lambda. You just basically tell it, I want the tier compilation and I want it to stop at level 1. And that's what that's going to do. Usually that's going to be, in most cases, it's going to be, really good for your Lambda. The only, some scenarios where that might not be a good thing to do is if you're doing something like, that requires a ton of executions, you're computing something or hashes or whatever, and you're doing over and over and over again. Don't do bit mining. You know, don't try to do that with this because it's not going to help you. All right. So, oh, shoot. This is set up the wrong way. Oh, all right. It is more comfortable. All right. So, we're going to eager initialize. One of the things to take into account is that when you're in that initialization phase, you actually get a lot more processing power, a lot more memory than when you're in your invocation phase, and you get it for free for 10 seconds. So that's how long the Lambda has to initialize before, you know, it sort of thinks that something is wrong. So you're getting this a lot more power for free to initialize. So one of the things you can do to take advantage of that is to initialize all your, you know, clients and things that take like that need a lot of processing power, things that, you know, are going to be a little bit are going to take some time. It's better to do it in the initialization phase. So basically what you do in order to get that done in the initialization phase is to put it outside the Lambda handler. So sort of like, you know, before your function. So it's like in a static block, for example, so that is going to survive from Lambda execution to Lambda execution. So if you initialize your first environment, that first invoke, right, with all of this, and then on that third invoke that reuses that first environment, all that is already there. You're not doing it again because the Lambda is warm. All that stuff, if it was done outside of the function handler, it's still going to be available for you. So you're going to basically spare yourself from having to wait for all of that to be done. Right. Another thing which I learned the hard way, use the Java SDK version 2, especially if you're having anything to do with like HTTP requests. It actually enables you to use a much smaller HTTP client, and that makes a ton of difference. So, you know, it has some other improvements. It's using the builder pattern and whatnot. It's now the constructor pattern is frowned upon for whatever reason. But anyway, it has a bunch of improvements that, you know, made with that in mind, like reducing and making things easier. All right. You should also try to take advantage of multi-threading, even if you are running on a single core. How many cores you get depends on what the memory setting is for your Lambda, right? So the bigger the setting, the more cores you get. But anyway, in any case, it's still good to use the threading, you know, to do some stuff in parallel. I think I even seen like the threading done in like, is that possible outside of the function handler? I think so. I think I've seen some eager initialization happening that way or something. I don't know. Anyway, so that way you get more stuff done, you know, and in the same time, basically. All right. So those were some of the things that you can do.
Yeah. So a lot of optimizations, some quick and easy, others a bit more effort. Nobody always wants to do all of them or can do all of them. But what we have now is Lambda snap starts. And if you do the other optimizations or not, the time you have with or without those optimizations, if you then enable snap start, you can have up to 10 times, quicker startups, let's say, for the cold starts. It is only the cold start that is the big problem. So what is snap start? Snap start, it's how you do it. You configure it to use snap start on the Lambda. You do it in the console. You check a box. You make sure that you create versions of your Lambda, and you do not always use the latest. You have to create versions, or you can do it in infrastructure as code as well. And that's all you have to do to enable snap start. And then what happens is you deploy your Lambda. It's going to do the initialization of this Lambda in a new environment. And once the initialization is done, it is going to take a snapshot and it's going to encrypt, store it in an encrypted S3 bucket. And then in a tiered low latency cache, it is going to make it available for when it's needed. So when it's done, then it goes to a state active. And from then on, every invocation to your Lambda is going to take a copy from the cache and it's going to do the resume and the invoke from there. And every time, every new invocation is going to come from this cache. So that means the whole initialization phase, it doesn't need to do that again if the invocations are already running and it needs more invocations. To be able to do that, there had to be some changes in the invocation model. So this part up until here, that's how it usually works, that we showed earlier. What we have now in the init, we have this pre-snapshot hook, which is optional, where you can do some things to make it run even faster with priming, for example, but we're not covering that today because it's a bit too much otherwise. And that is the entire initialization phase now. And then what you could see on the previous slides, every time you do an invocation, you have two steps now, a resume and an invocation. The resume part here is also the new one. So the resume snapshot means I'm getting it from the cache, I'm starting it up, and I have a post snapshot hook that is optional. So to use snapstart, you can just enable it and not do anything else. If you want to, let's say, advanced snapstart user, then you can also start playing around with those hooks to do extra things or to make it more advanced and everything. And then once the resume is done, you have your invoke like you would have it without snapstart. If you then look at test results, we have an application, a Lambda, that with a Spring Boot application in there that is getting an API call and is writing something to DynamoDB. If we do it without snapstart, it is 8 milliseconds to do it with a warm start. The extreme, when a cold start is needed, so the P99, it is 5 seconds. If you enable snapstart, the normal usage is still 8 milliseconds, so nothing changes in the warm invoke, let's say, but in the cold invoke, we go to half a second. So that is a big impact. You can get it even lower than that if you then also start doing all of the optimizations that we discussed earlier, and if you do priming for snapstart functions and so on. But this is already a big change. So with all you said, you can think, oh, great, that's interesting, I want to do that, but I can no longer easily say, it runs on my laptop, so nothing is wrong with the application. Well, it is cloud, so some things you will have to do in the cloud, but even with Java in serverless, you can still do stuff on your laptop, and you can say, well, it runs on my laptop. So one of the things you can use for that is the AWS SAM. So you always have to think serverless application model. It has two things. First part, we're not going to talk about today. It is the let's say an easier format for your infrastructure as code in CloudFormation, which is our infrastructure as code platform. SAM is for serverless application, makes it a bit easier to read the declarative file. The other part of SAM is the command line interface. And in that command line interface, it allows you to build locally, to test some things locally, and then also to deploy from your laptop to deploy it to the cloud. And some of the things you can do is you can do a local start for a Lambda. So you can say, well, I have my Lambda, I have my unit tests, those are done, but I also want to see it run and do some testing that way. You can do that with the SAM CLI. The other thing you can, so you can do some CLA invocations, and you can, those are the things you can test, the CLI and the SDK invocations that go to a Lambda. What you also can do is, well, depending on the architecture, you have one big Lambda, a monolith Lambda. It exists. You would think not, but it exists. There are customers that we built a serverless application, and when I say, okay, and we have problems because it is too slow, and Lambda, if you know or not, it has a timeout after 15 minutes. So a Lambda function can only run for 15 minutes, and then it stops. And so each invocation is 15 minutes. So some customers, the customer once said, I'm building a Java serverless application, and it's never able to finish with all of the data processing it needs to do. Okay, show me the architecture. And they drew API gateway on the board, and then, so they drew this, and then this, and that was it. I was like, and the rest? No, that's it. Okay, so fine. You can do a monolith Lambda. Don't do that, but you can. Don't do that. Or you can say, well, each each DP verb has its own lambda. That's the other extreme. You can also do that. I would also not always encourage to do that, and everything in between is possible. So imagine you have your application with 5 lambdas, or let's take three lambdas in this case. You can also test the routing of the application that is in API gateway, and then the lambdas. Why? And then some will say, well, why do I have to use API gateway? I already have Spring Boot and I have my controllers in my code. You can do that, but that's another. Let's say it can be. I forgot the word. It can be boilerplate code. Your controller sometimes it's boilerplate. Nothing much happens. You get your payload in, and you pass it on to the next layer, and that's it. Some do more, but sometimes it's also that. So then you can say, well, I take it out. I use API gateway, and then you have another product for today, API gateway, and then you have other functionality like throttling that you can enable, or like using API keys or whatever. So you can test the routing and then the application on your laptop. As you've seen with the one of the first slides about Lambda, you can invoke Lambda in 3 different ways. A resource state, for example, an EC2, a virtual machine that started or stopped. It will trigger an event, and a Lambda can look at that and it can do something, or it's an HTTP call, REST call, API call, WebSocket, whatever, or it is an event. So you can also generate events from, and here's a list of the services. From all of those services, you can generate an event that you can then use locally to test, to see how your function would work with that. And that allows you to send that event to your Lambda to see, does it pick it up? Can it read the payload and the context and everything around it? So if you have business logic in there to do some, let's say, meta business stuff, to check from where it comes, or other things you want to give us metadata in the payload, you can also test those things. Sometimes that's not enough. By the time I stopped, I was using, and that's, I have to see, I stopped as a Java developer in 2012, 2013, something like that. And at that point, for me, the hot thing was hot swapping code in an environment. Changing some code on my laptop, I don't have to do anything, and the environment over there has some changes. Well, you can do that as well with some accelerate. You can ignore the build part. That's like Maven. You can have modules, and you can build each module separately and so on. But it's something you can, if you do that command on your laptop, from then on, all the changes in your Lambda or in your infrastructure as code in the SAM template, that is, I think it's then only step functions and API gateway. Those changes will be propagated immediately to your environment that you're connected to somewhere in an AWS account. So you can make changes without redeploying. And the other thing is, you can then also, from that environment, you can get all the logs on your laptop as well. If you want to have fun diving through all of those logs on your laptop instead of whatever logging platform you're using. So if you look at the development cycle, then it means that, well, create, that's like creating your Maven project or your Gradle package project. You do a SAM init, you have your skeleton for your infrastructure as code, and then in there you can also have your Java functions. And then the local testing, you have the invoke, start API, and so on. Remote testing, you can connect to, do some live changes, and then from there, the other environments, we suggest you not do the remote testing and the remote changes. But again, not everybody always listens, so sometimes it happens as well. But yeah, fine. So another thing that can, so this will help you. Another thing that can help, it is serverless, so some things are different, but the Lambda Power Tools for Java can also help by, so you can scan the QR code, by giving you artifacts that in your code to enable observability, to make sure that all of the logging, no matter how many Lambda invocations there were, all of the logging is saved in CloudWatch, so you can always find it back. Because that's one thing I learned the hard way in the beginning. Yes, we have a cluster of servers. Something went wrong. Oh crap, that server is gone because we downscaled. So if that's not a problem, if you use the logging functionality of Lambdas properly. Other things is caching or handling secrets, all of those things that are in the power tools to you to easily build your Java applications in a cloud-native way. If you want to dive deeper on this, if you want to do something yourself, Java on Lambda workshop, you can scan the QR code or you can just Google it, is a workshop that you can do yourself, or if you want to do it with the entire team and you want some AWS assistance, that you can also ask your account team to come and help you in going through this workshop. So you're going to, and this is an old screenshot, you're going to go from a serverful application, Spring Boot, to serverless. So you're going to put that Spring Boot application on Lambda or monolith Lambda. And from there, you're going to make some changes to make it quicker. You're going to have, you have a section where you're going to use GraalVM to improve the speed of your Lambda, let's say. And then the third part, but it's not on the screenshot here, is then doing it with Snapstart as well, which is shorter than the others because it is very easy to enable. Questions? I think there was a question from there.
Yeah, well, I was referring to the, say, first way of having Java lambdas. So you showed that if I have one request.
If you have one request, no, going way back.
The concurrency.
Yeah, probably.
Slide 11.
Yeah, in
so-
this case. So we have our Lambda in this first call. So we are going to have this initialization process and then invocation.
Yeah.
Fine. Then another request comes, another environment is created. They are not sharing anything. And then a third request comes and it will share the same environment that was created before.
Yes. Why? Because the invocation here was done.
Yeah,
And the environment was still alive.
exactly. That's my question.
There is no guarantee that a warm environment will be used. We will reuse, but there is and I don't know what the time limit is, but there is a certain time limit that the environment will stay alive after it's done with the invocation.
Okay.
If in that time frame there is a new invocation, it might reuse it.
Will I pay too for that time that it is just waiting? No, in the warm status. Okay.
And it's usually
so
20 to
here-
40 minutes.
Yeah. Here you pay for this.
So
So the first invocation, you also pay for the initialization. And then here again, the entire package, let's say, for the second one. But the third one here is only for this part.
Okay.
So you do not pay you do not pay the wait time that the environment stays warm. You pay for the actual use of the environment. We keep it warm sometimes for whatever reason, I don't know. But you don't pay for that part.
it can be, there's no formal answer to how long it can stay warm, but usually it's 20 to 40 minutes. So you have a good chance of getting on, a warm environment on another invocation, but there's no guarantee. So, yeah.
Any further questions? No one? Yes.
All this applies to Kotlin too?
Yes. Well, there was even a slide of an optimization, but I removed that one for to keep everybody sane and happy. But another possible optimization is use Kotlin for some parts. So yes, it applies for Kotlin as well.
But I think Kotlin, it loads less, right? So it doesn't have to load as many classes, so it's a little bit smaller footprint for the framework.
Any other questions?
Well, in that case, many thanks for your talk, Kevin and Melina. A big round of applause for them. And Gustavo? Gustavo has a message for you too.
Yes. The most important thing, the food. There is a canteen in this floor down the hallway, and there you will find pizza. I don't know what else, but if you want to spend more time with us and share with us all your knowledge or whatever you want, you are all invited to spend your time with us there. So I hope to see you all there.
One thing I forgot.
Thank you for coming.
If I may, I have a bunch of Java performance articles on Medium, so if you're interested, just look me up. And there's plenty of stuff.
So that's it. That's it. Let's go to have some pizzas.